Hello everyone and welcome to another video where we will be solving an exercise, a very complex exercise on integration using the method of by parts. So let's get right to it. Our exercise is e to the power of x times sine of x dx. And we need to solve the integral of this. Well, first off, we will be applying by parts. We have to choose one of the two to be our u. Now, remember, by parts is all about trial and error. There's no exact way of knowing always how it will work, so you have to just keep trying. If you choose this as your u and this is your dv and it doesn't work, then try the other way around and see if it works. And if not, keep trying different variations of the by parts. So, I'll select my u to be sine of x and my dv to be e of x, as usually your dv should be what is easier to integrate. In this case, e of x remains e of x, so it is easiest. Then du is just cosine of x, and v remains the same, e of x. So, applying our formula, substituting these values back, we get u times v, which is sine of x, times v, e of x, minus the integral of v, which is e to the power of x, times du, which is cosine of x. And we have, again, another integral here that we have to also solve by parts. Sometimes, in some exercises, you will have to apply by substitution 2 times, like we saw in another video, or you will have to apply by parts 2 times, like what is happening in this video. So, let's just take this and say that u is equal to, let's say that our u is going to be equal to cosine of x, and that our dv is going to be equal to e of x. Remember, if you choose that this u is e of x and this dv is cosine of x, maybe you will still get a solution, but maybe it will take longer or shorter. And if you don't get a solution, then just go back to this and solve using u as cosine of x and dv as e of x like I have done here. But you can do it whatever way you want. And then du is equal to minus sine of x, of course, and v is equal to, again, e of x. So if we solve only for this, we know that this is going to give us u times v cosine of x times v e of x minus v e of x times du minus sine of x minus sine of x. And this is basically going to be cosine of x times e of x. Here we have a minus and we have a minus multiplying. This is a constant here, minus 1 multiplying this whole integral. We can just take this minus 1 out. Minus times minus 1 is plus e to the power of x times sine of x. And now let's substitute this back into what we had here. Sine of x, well, e to the power of x times sine of x minus cosine of x. Well, let's say, to make this more simple, e of x times cosine of x minus e of x sine of x. And you may think, well, what, do we have to apply by parts again here? And the answer is no. You have to take a close look into your exercise and see that this right here, e of x times sine of x, is the same as what we had to solve in the beginning. So it would be absolutely useless to try and apply by parts to this, as we would just keep getting the same that we have gotten now, expanding this integration again and again and again, expanding it more and more and more. What you have to do here is just equal this. You equal this to what we have here, the problem we are trying to solve. E to the power of x times sine to the power of x dx. And once you have this, once you have this, sorry, I had to erase the board to get it back. We had the integral of e to the power of x times sine of x. This is what we want to solve. This is the problem we were given, is equal to e to the power of x times sine of x minus e to the power of x times cosine of x minus e to the power of x times sine of x. We cannot do by parts here, as I said before, as you would just keep going in a loop. And what you have to do is see that these two are exactly the same and move this to the other side, which it would be adding, and e to the power of x times sine of x plus e to the power of x times sine of x is just 2 e to the power of x times sine of x is equal to e to the power of x sine of x minus e to the power of x cosine of x. And now all you do is isolate this by passing the 2 to the other side, dividing. So we have that e to the power of x times sine of x, our original problem, dx, is equal to e to the power of x sine of x minus e to the power of x cosine of x over 2, and then plus our c, of course. And this is the solution for this equation. And yes, using by parts, you can move one side, like your answer, you can move it to the problem you are trying to solve in order to solve your integral. Thank you for watching. That will be all for integrals using the method of by parts. And check out my next video, in which these videos we have been looking at indefinite integrals, and my next videos will be looking at definite integrals.